We made an earlier video on outputting to the screen and outputting to the serial and making it alternate by pressing the F1 key. One of the annoying things, though, due to the missing hardware handshake on this card, is that you're really limited in the upload speed to the card. But a lot of times, for instance, if you're downloading, you might want to go quicker. Certainly not an issue for pressing buttons that run at 300 baud, but wow, it's really inconvenient when uploading programs to have to recompile. So what I thought I'd do is assign the function key 2, F2 key on the keyboard, to switch between the serial rates. Let's see how that works. I've already pressed the F1 key to switch the output to the putty application that I'm running here, and currently I have it set for 300 baud. There's no program loaded at the moment, but if I want to upload a program, I just copy it out of Notepad++ and paste it in the other screen, and you can see from the speed there just how slow it is to upload a program at 300 baud. And of course, if you want to run the program, you just type run, and it does just what Hello World should do, but it's slow even on printing. Now if I press the F2 key on the keyboard, and if I tried to type, it would be bad because it's still running at 300 baud, but the card is now running at 115 2K baud. So we need to switch the program, the putty program, to be running at the right speed. The way that I do that is to go to the connection serial and set that to 115 200. 115 200. Got it. Apply it, and now if we do list, it lists much quicker. And run is instantaneous too. So the card is running at 25 megahertz right now processor speed, so it's definitely set up to be pretty fast. If you're downloading, you can download perfectly fine inside a putty by going to logging and turning on a log here. Right now it's not set to log, but all session output could be logged, and then anything that comes out of the screen would be logged to a file. The change is very similar to what was done for the F1 key for switching the serial between the two interfaces. I'm using the exact same toggle on FN key module here as well. In the microprocessor VHDL file, I've added a signal for function key 2. I routed the function key 1 to one of the LEDs, and I haven't routed the function key 2 to one of the LEDs, but that could be done too, just to tell which baud rate you're in. This requires inserting another entity for function key 2, and it's identical to the one for function key 1, except it uses the key at offset 2, or the bit at offset 2 rather than 1. I don't know how 0 is used, but the keys on the keyboard, function key 1 through 12, seem to map to 1 through 12, and 0 seems to be unused. I tried to use the bits that are the toggle bits inside of the terminal text display, but wasn't able to get that to work after fumbling around with it for about an hour. So I switched back to my tried and true method here with this edge detect latch method. The edge detect and latch method, I described it in the other video, but basically it looks for an edge on the function key button. Those are only present out of that text display RGB when the button is being pressed, so it goes away. You want to keep it set though, and what this does is toggle every other time the button is pressed, so you can stay in whatever state you want to stay in. The last step was to just select the divisor based on that function key 2. If it's 0, then it comes up at 115 200. If it's 1, then it comes up at 300. This is certainly a lot more efficient, easier way to switch between baud rates rather than recompiling the FPGA. Here's where those counts come from. Depending upon the baud rate you're running at, you load a different count into the direct digital synthesis, the DDS counter. It's I believe a 16-bit counter, and you add on the offset, and the calculation takes the baud rate, and the UART needs a 1 in 16 or 16x clock. The CPU's or the microprocessor's clock is 50 megahertz. Looks like there's a typo there. Let's fix that while we're here. Might make some of these numbers round a little bit better, slightly. That 16-bit counter counts up to 65,536, but it adds this count at every increment to create a nice clock that's fairly well synthesized. The numbers aren't exactly round, they're pretty close, but if you round it, they're good enough and they work, particularly with the 16x clock. So for 115-200, it's 2416, and for 300 baud, that divisor is 6, and we can see that back here in the original code we were looking at, where it's 2416 or 6, and that's selected again by the function key 2. Hopefully this gave you some ideas, and if you struggle with this, I really wish the card had that hardware handshake, because we could just run it 115 too. The UART looks like it's well designed, that when it gets full or half full, it signals out through that request to send to the FPGA actually should send out to that the UART, the USB to serial UART, but the card doesn't have a connection between those two. It's not a fatal flaw. There could be a program written to upload that would wait till a character came back as an echo, for instance. There's probably other ways to get there. There might even be a way in PuTTY that I'm unaware of what sort of pauses you could put in or some other sort of settings, but I haven't seen anything in the screens here that tell exactly what would do that, and I'm not even really sure. There's nothing there. There's times between keep alives, that wouldn't work. Obviously not colors, that doesn't help. Selection doesn't work. Behavior. I apologize for the Saturday traffic outside my window here. Just too beautiful today to keep the window closed. Anyway, there might be a bit in here somewhere, something to set that I'm just unaware of, and if anybody knows in PuTTY, that information would be appreciated. Anyway, thanks for watching. I thought I'd throw this quick video up here as a way of expanding the function keys. I might hook up some of the other ones to other things on the card and see what we can do there. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.